Now consider the following function f of x1, x2. The first question is, what is the direction, in what direction f decreases the most rapidly at the point x0? So we know that the gradient of f at the point is the fastest increasing direction, okay, or the direction that increases the most rapidly. So the negative of gradient will be the direction that decreases the most rapidly. So we just need to find out the negative gradient of f at that point. Okay, the gradient of f, the f is here. The gradient is just this. Okay, and the point x0, which is 2, 2, 2, 1, which is I need to plug in x1 equals to 2 and x2 equals to 1. Then we'll figure out this gradient of f at the point x0 is just a 5 and 10. Okay, usually when we say direction, we mean that it's a unit vector, so we don't want to introduce the magnitude, so we can compute its magnitude and normalize this vector. The magnitude of this vector is just the norm, which is just the square root of 5 square plus 10 square, and that is that. So the direction of fastest decrease will be just the negative gradient direction. So let's call it u, and this should be negative of the gradient, and I'll normalize it, want it to be unit vector. So that's how we just put this here, and the denominator, which is this, over here. So when I do the computation, I'll get this value. So that is the u, which is the direction where along which f is decreasing the fastest. Okay, so that's the part A. The part B says that what is the rate of increase of function f at the point in the direction of the maximum decreasing of f. So we already computed the direction of maximum decrease, which is the u here, and to compute the directional derivative, we just need to take the inner product of the gradient of f and this vector u. Okay, so we just need to do that. So this is the gradient of f, and this u, actually we compute this u based on that. So we just need to plug this in here. Okay, or you can just directly compute the value here. It'll give you the same result. But I would take a shortcut, because this, when I put in here, we'll see that this is the same vector, okay, except that it's unnormalized. And just multiply the two. So the numerator will be just this, and this, and multiply these two together. And that is just the square norm of gradient of f. And that will cancel, one of them will be cancelled by the denominator here. So that's why I only have the norm of gradient of f. And there's a negative here, so I will still keep it here. So the norm of this is what we already computed, and that is the 5 root 5. So the gradient is negative, so the directional derivative is negative 5 times root 5. The third question says that what is the rate of change or rate of increase of f at the point x0 in the direction of this? So we just compute the directional derivative of f along that. Again, we're going to normalize the d. So let's call the normalized d v, and it's just d over the norm of d, and the d is 3 and 4, so the norm of d will be 5, because it's the square root of 3 squared plus 4 squared. And that's the unit vector v, and then we take the directional derivative, which is the inner product of the gradient and the vector v here. We'll have this, this is our gradient of f, which is 5 and 10, and this v is what we just computed here, so eventually you get 11.